Hello, welcome to my pipeline, which developed to extract financial rules from the structured or unstructured PDFs and generate SQL from that. So this is the workflow from of my diagram. Initially, actually, I start with processing, document processing, where actually my model takes PDF documents from Google Drive, then like chunks, extract chunks and use the chunks to feed into the LLM and extract JSON structured rules. And I'm using Gemini 1.5 Flash for that. Then I encode that into Cipher and I upload that structure rules to knowledge graph. I'm using Neo4j or a knowledge graph. Then I'm using a rule retrieval module using GraphRag that search any keywords and extract relevant rules. And then I generate codes which uses the rules extracted from the knowledge graph and that table schema that institutions database that extracted using a tabular rag. And for that purpose, code generation purpose, I'm using Mistral. So the basic output is the rules in JSON format, knowledge graph in Neo4j, and dynamically generate SQL queries. Yes. So if I go to the workflow, this is how my workflow goes on. I take the documents, I create prompt the LLM, create prompt with and using LLM I extract JSON rules. From the JSON rules I extract cipher queries, and then I upload the knowledge graph, and then a user can query using a graph rag query the knowledge graph and extract some rules, and using that rules they generate a dynamic prompt, and that prompt also includes the database schema like more similar entities from the rules, and that included in the prompt, and LLM takes that and generate the SQL and which can be applied to database. So initially, this is how actually I add all the necessary materials for like install all the necessary packages for my model. Then my first extraction is part is rule generation pipeline. In the rule generation pipeline, I first connect to the Google Drive to dynamically extract the documents. Then I extract the from the documents materials. I extract the JSON rules in a structured format where I use the following format. The every rule will have a rule ID, the whole rule from the unstructured rules, then and the condition of the rule, action of the rule, and which regulation it belongs to. Then also I check the rule generation evolution, like how good my rule generation pipeline performs. So this is the Google Drive version where I'm extracting the PDF like a real live world synthetic data, PDF rule synthetic financial compliance, which saved into the Google database. This is where I'm extracting them. And this is the this is how I'm using the extraction using JSON format using Gemini 1.5 Flash, where actually I used in this format. You can see that ID, a full rule, and the condition ended. So in the Gemini to the Gemini inference, I'm using model as Gemini. I using the following format where I'm using few short format where I'm providing few sample rules that needed to be extracted from the document text. And this is, and then I'm just inferring to my LLM, and you can see that this is the rules I'm extracting, which pretty much following the structure I provided to that. Then I evaluate like the performance of my rule generation pipeline, if how much similar and partially, like how much partially recovered or similarity or missed. And from the pipeline, from the rules, I can see that This is the hard-coded rule from the same document from where I extracted the rules, and this is what I expected to extract, and this is where actually what I'm comparing it against what my LLM extracted. So overall, when I measured the accuracy, I only accurately only 30% rules accurately recovered. Partially recovered is 0.3%, and similar is 0.7%. But I missed 59%. Average similarity is 77, and average correct similarity 40%, and related excess extracted rule is 37%. So then next portion is uploading the rules to the Neo4j knowledge graph. So initially I checked I am using Aura database, which is online, so I don't need do not need to create any local schema. And in the here I'm first creating like connection to the Neo4j database. You can say it. Next question is creating the cipher code. So I'm taking the rules, JSON rules, and I'm just creating here. I'm creating the required ciphers, and then I'm uploading this rule to the Neo4j and uploading that to the Neo4j database. Then this is the query portion of the database, and this is the portion where actually I developed to check query the database based on some items. For example, a user can just query a credential and a credential, and it will go to the database, and every rule with credential has in it will be extracted. You can see that it is extracting it based on this. So it is a item like similar to graph rag. So then actually using that formula, I'm extracting rules using similar to GraphRag. So the code generation, for the code generation part, the third part of my item is the code generation, where a user first will query the knowledge graph and extract the rules for related to some keywords, like here credential, it extracted the similar rules. Then using that rules, it will use a tabular rag, and from that tabular rag it will extract the table schema, and from the table schema it will identify the necessary entities from the listed within the rules, and using that necessary entities and the rules, it will create the SQL. So what happening here is first it creates the table schema using a tabular rag. So first I'm uploading the table schema from the database, which is I'm using as I'm reading as a Excel file from the Excel file. Then I'm creating the tabular rag, and then I'm just feeding the rules, every rules into it, and for each rule I'm extracting the relevant table entities for that rule that needed to be accessed using that tabular rag. Then you can see for each rag, this is the table schema I got. Then what I do is, like, now I create a dynamic from that tabular rag and everything. I just this is the tabular rag portion actually there. So this is the rule, and for the schema I'm extracting, and this is where actually I'm creating the vector database of the table schema. So I need for the tabular rag, I need a vector database, and this vector database is accessed using this face here. For each I'm feeding into the I'm using a rag, and I'm feeding the rule, each rule, and say I'll also feeding the vector database and saying like access the most relevant entities from the table schema from the table schema vector database, and it is accessing, you can see it is accessing relevant entities. Now what I mean is, now I'm creating to generate code, I'm using a dynamic prompt. So here the full rules are added in the prompt. You can see that also the schema also the added. Then this dynamic prompt is fed into the my Mistral LLM here, and asking it to generate from code, SQL code. And you can see that this is the SQL code it is generating. It is pretty much generating this SQL code based on this LLM. Okay, this is the final SQL code it is generated. So this is my full pipeline and how it can be improved. For example, what we can include few short learning for rule generation. In case of GraphRag, we can use semantic rules to generate like more meaningful rules dynamically. For more better SQL generation, we can use a vector database of SQL and use few short SQL generation that will improve like code generation. And then we can check also SQL code safety so it doesn't modify the database and efficiency to run it. So here is the my future version where we take the document to upload the chunks and we just there is a vector database of a structure of rules. Here, before rule generation, we can use few short more similar rules from the chunks for each chunks. Now that will make the rules more efficient. Then here actually we change the normal knowledge graph into semantic knowledge graph. So now actually we find more relevant rules based on any semantics. Then we access GraphRag and everything. And for the tabular to generate better SQL, we can use like vector database with example SQL queries. What happened is if we use that, then now we have like more for this type of entities and this type of rule. What is the most efficient SQL query prompt will have that, and LLM will generate more efficient SQL code. Still, that might hamper the database, so we will have a security checking data module that will check security if this SQL is efficient or it is dangerous. Then we can access the database. So this is the my whole outline of my pipeline and the futuristic version what we can follow to improve this pipeline. Thank you. Thank you.